Welcome to your Newton online class. In this video, I want to solve a particular question on the board, which is a question taken from friction and inclined plane, that is machine. Okay, let's look at the question. A man pulls up a box of mass 50 kg using a plane inclined at 30 degrees to the horizontal. If the friction force between the box and the plane is 1000 Newton, calculate I, the minimum effort applied in pulling up the box, II, the force ratio. Now, let us proceed to the solution of this question. Now, this question involves inclined plane and also friction, that it is machine. Now, first of all, we have to interpret or analyze this particular question mechanically by drawing the inclined plane. So this is the box. This is the inclined plane. Here is the angle, 30 degrees horizontal. Then, now we are told that the weight, the mass of the plane, the mass of the box is 50 kg. Okay, so this is the box of 50 kg. Then, now, for us to obtain the minimum effort applied by this man in pulling up this box upward here, we have to consider the frictional effect and the weight, the force due to the weight of the body along the plane. Because this body now has component of its weight along the plane and component of its weight down the plane by vector resolution. This is the effort, since the man is pulling the body upward the plane. Then down the plane now, the frictional force is opposing the effort of the man. So have friction here. So let this be the frictional force opposing the effort of the man, the force being applied by the man to pull up this object. And also, it should be noted that this is the normal reaction. Here will be normal reaction. Then this is the component of the weight. Component of the weight of this box down the plane. Then along here we have along here we have the component of the weight of this box along parallel to the plane, along the plane. And that by vector resolution, the component down along the plane is weight sine theta, because the component of acceleration due to gravity g along the plane is g sine theta. Then the component of the weight of this body down the plane should be in the horizontal component here, should be by vector, will be here, should be w cos theta. Then this is the effort. So for the man to put this body upward, he has to counter these two forces. Force due to the weight of the body acting downward, then frictional force opposing the motion of the body along the plane. So that way, the sum of that will give us the minimum force required by the effort of the man to pull the body up. Now, working on it now, we now have that. We now go to the question I. But recall that weight, the mass of the body is given in kilogram. So we have to change it to Newton first, that is weight. So we should recall that weight equals mg. Therefore, our W cos theta here, W sine theta will now be mg sine theta. That is it. We take note of this first. Then we now continue. Therefore, the question I, the effort, the minimum effort E will be equals to the frictional force plus the weight of the body along the plane. That is frictional force plus mg sine theta. That will give us the minimum force or effort required by this man to pull this body upward. Now, putting our figures there, we now have that effort is equivalent to frictional force given to us in the question is 1000 Newton. Plus the mass of the body is 50 kg. Then acceleration due to gravity is 10. Then sine the angle given is 30 degrees. This will give us 1000 plus, we have 50 times 10, that is what? 500. Sine 30 is 1/2 or 0.5. Then, or let us use 1/2 there. Then we have this, giving us 1000 plus half of 500 is 250. Equals 1000 plus 250 give us 1250 Newton. So this is the effort required by the man to pull this body upwards. Now, you know how we got this? 2 divided 500 get 250. Okay, now the next question now, we are asked to find the force ratio. Now, by force ratio, we mean mechanical advantage in machine. That is the force ratio, which implies the ratio of the load to the effort applied. You put the formula. The force ratio which is MA equals load over effort, which is equivalent. What is our load here now? In the question here, our load is that box. That's the load. And that load is given in kilogram. And we have to convert it to what? Newton. That is in form of weight. Then we now have that the load now is 50 times 10, which is 500. Over our effort is obtained here to be 1250. So we now divide. We have 0 cancel 0 here. Then we have here 5 can divide this to give us 10. 5 divided 125. We have 25. Then 5 into here gives us 2. 5 into here gives us 5. Then when we have 2 over 5, it simply implies 0.4. Let's check it out here. That is 5 divided 2. We have 0, decimal, put 0. 5 divided 20 is what? 4. So 2 over 5 is what? 0.4. Therefore, the mechanical advantage or the force ratio is equal to 0.4. Thank you. I hope you enjoyed this solution. For more solutions in physics and mathematics, kindly visit my YouTube channel, share and subscribe.